be given an actual function. We're going to be given what the original function looks like, and from there we want to figure out what would the derivative look like and what would the second derivative look like if we're trying to graph them. So what we're going to have to deal with is, what do we know about the original function and how does that help us to graph those other ones? So I'm going to start with this one by thinking about, if I want to graph the first derivative, I want to think about the slope of this original function. The first derivative is based off of the slope of the original. So I would say for this original function, from negative infinity to 2, this has a positive slope. So that means that my f prime values are going to have to be positive from negative infinity to 2. Right here when x equals 2, what's the slope right there? 0. What about from 2 to infinity? What's true of the slope? It's negative. So I have to come up with some graph that has positive values, then a 0 value, and then negative values. When I say values, I'm talking about y values. See, the derivative is graphed. These x's result in these y values. So all of these x's have to give me a positive y when I graph f prime. This x value, y has to be 0. So I'm going to go ahead and plot that point. There's that one. And then I want to think about the fact that for all these x's, I have to have negatives. Now also think about this. If we have a parabola, what's the derivative of a parabola going to have to end up being? It's going to be 2x, right? Now this isn't just x squared, so it's going to, but it has to be a linear term, is what I'm saying. So if we have a parabola, the derivative's function is going to have to be a line, an oblique line, in fact. Oblique just means slanted. So the line that I draw has to have positive values, then 0 as a value, and then a negative values. Which would it have to be? Is it going to be A, B, C, or D? Which one is going to have positive y values, then 0, then negative? I'll go through them again. A, B, C, D. What do you guys think? B is right. Yep. It's going to have to look like this. And I don't know exactly what this is going to be. I just know that it has to have positive values, then it has to be 0, and then it has to be negatives. That's the only way it's going to work out. That's what the original is going to, or the first derivative is going to look like. Now, here's kind of a cheat that I could do to check it. I know what this original function is. I don't know if you guys would remember this, but this is going to be negative parentheses x plus 2 squared plus 3. The way that I know that is because this is a parabola that opens down, so I had to have a negative. It's been shifted to the right 2 units. I take that back. It's actually minus 2 to make it shift to the right. And then it's been shifted up 3. I don't think everyone would know that, though. Okay? Now I can have my calculator graph this. What I want to do is I'm going to go under Math, and I want it to graph the derivative. So I have to go to InDeriv, and I would have to have this typed in. You don't need to do all this. I'm just showing you a way you could check it. I'd have to put this in. And now when I graph it, I'm going to make this a different color or boldness. So here's what the original function looks like. Looks like that. And then here's what the derivative looks like. Now the reason mine doesn't look like it goes as high is because I didn't do a zoom 6. So here's the function, here's the derivative, so we can check it that way. Okay? If you can figure out how to do that, you're welcome to use that to help you. For the second derivative now. The second derivative is based off of the concavity of the original function. This original function, from negative infinity to infinity, what is always true of its concavity? Is it positive or negative concavity? Negative, right? Because it's opening down, so it's concave down. So I now, if I'm graphing the second derivative, I have to have a function that always has negative values. Would I want to graph a line like this? Would it be A, B again, C, or D? Which one would always have negative values? D. I don't know exactly where it's going to go, but it's going to have to look something like that. And the other way I know that is because this is the line like y equals negative 2x. And what's the derivative of y equals negative 2x? Just negative 2. So it would have to be this line. A way that I could do it on the calculator, this gets pretty tricky, but I would now have to go to math. I would go down to my n deriv, and I would have to say, with respect to x, now take the derivative of the second function. So I'd have to go to y bars, y2. And now I'm telling it to graph the derivative of the second function. So again, there's the first, there's the second, and now it takes it so long to graph this one because it's trying to compute the slope at every given point. So it's very slow. We're not going to wait for that. All right. Number 2, we're going to graph the first derivative. So between negative infinity until I get to negative 1, what's true of the slope? It's negative, right? So my values are going to have to be negative. What about at negative 1? What's true of the slope? 0. What about between negative 1 and 1? What's true of the slope? What's the slope here, guys? Positive. And then at 1, I can see it's 0. And then from 1 to infinity, the slope is negative. So I have to think of what kind of function would have negative values, then 0, then positive, then 0, then negative. What type of function is this? What power is it probably raised to? To the third, right? Some of you are kind of whispering that. Yeah, this would be to the third. If I take the derivative of something to the third, what is it? It's to the second, right? Don't we subtract 1 from the power? So I would now need some kind of quadratic function that has negative values, then 0. I'm going to go ahead and plot the zeros. So it has to go negative, positive, negative, and it has to be a parabola because this is a cubic. The derivative of a cubic goes to a parabola. So I could have two options. Is it going to be option A, a parabola that opens up, B, a parabola that opens down? B, doesn't it? Because my values have to have negative values, then positive values, then negative values. So it would have to look like that. If you know enough about the looks of functions, I know that this has to be a cubic function, like I said. It's actually going to be something like negative x cubed, and then it's been shifted up 4 units. That's close to it. May not be exactly what the function is, but that's kind of close. In fact, it probably isn't going to have the curvature it needs. But that can give us some idea. Like I said, it's not going to have that exact curvature. But I can still see that the derivative ends up being a parabola. This parabola is a little bit different, but at least we would know that it opens down. Okay? All right, now let's do the second derivative. That has to do with the concavity of the original. Right here, the concavity is 0. So I know that when x is 0, my concavity is 0. I know that if x is in between negative infinity and 0, what's true of this concavity? It is concave up, which means that the concavity has to be what? Positive, right? Concave up is positive concavity. From here to here, from 0 to infinity, we have it concave down, so we have to have negative concavity. What type of function should we have if we're going from a parabola? What was the derivative of a parabola? It was A line, an oblique line. I know I'm going to have the point 0, 0. I know my function has to have positive values, then negative values. Is it going to be line A, line B, line C, line D? Spencer, what do you think? A? You're right. Thank you for not making me go through all of them. It's going to be this one. Okay? And that should make sense based off of the other one. This one went to that. This one goes to this. Okay? All right. So that's one part we're doing. The next part is if we're given clues, coming up with the original function, f of x. So they're going to give us a bunch of clues. We want to try to figure out what did that original function look like. It says to graph the function f of x. So f of 3 and f of 5 equals 0. There's no prime here. There's no double prime. These would just be telling me points. Just telling me points. Does anyone know what points they're giving me? What is it, Nick? They are, yes. So they're telling me these points. 3, 0, and 5, 0. They're telling me those x-intercepts. So right there and right there. I'm going to plot things as I figure them out. F prime is going to be negative if x is less than 4. That's telling me from negative infinity to 4, f prime is negative. What does that mean about the function? Is the function going up or going down if f prime is negative? What, Natalie? Down, yes, so it has to be decreasing. F prime of 4 equals 0. So at x equals 4, the slope is 0. We're going to think about what that means here in a minute. F prime is greater than 0 if x is greater than 4. So from 4 to infinity, I know that my slope has to be going up. My slope's positive, so it has to be going up. Now, if my slope goes decreasing to increasing, what does that mean we're going to have right here? My slope goes from decreasing to increasing. We're going to have a minimum. Good. This is the last clue, and this is an important one. F double prime. Peter, what does double prime tell us? Yeah, and it tells us what? Slope, point, concavity. The second derivative is going to be what? Concavity. This is telling me right here that it's always concave up. Because if that second derivative is positive, it's concave up always. So can you think of what kind of shape this is based off of all those clues? What is it, Paige? It's a parabola, isn't it? It's got to be a parabola that opens up. This concavity was the final clue that helped us to know that. It had to be always concave up. Let me tell you some things that other people have said. Some people said, why couldn't it be like this? Does anybody know why it couldn't be like this? They're like, yeah, look, it goes decreasing to increasing. It should be able to look like that. It doesn't have any concavity, does it? This doesn't have any curvature to it, so it can't be that. Also, what's true of the slope right here? Is the slope right here 0? No, it's a sharp turn. So on this one, this slope does not exist. They don't tell us that. Some people said, yeah, well, what about this one? Couldn't it be that? That bird shape, the cusp? What's this concavity here? Is that concave up? No, it's concave down. Same reason. Concavity's wrong and the slope slope right there is wrong. Okay? But these are some shapes we could get. Okay? So just keep all of that in mind. All right, let's do this last one. So f of 0 equals f of 2 equals 0. Again, that's telling us when x is 0, y is 0. When x is 2, y is 0. So it's giving us those points. Telling us this point and this point. F prime is greater than 0 if x is less than 1. That's from negative infinity to 1. What's our function doing? Is it going up or down if f prime is greater than 0? It's going up, isn't it? It's increasing. Okay, now this is a little different. F prime of 1 does not exist. This can mean two things, guys. This can mean a sharp turn, or it can mean a vertical asymptote. We don't know which one it means yet. F prime of x is less than 0 if x is greater than 1. So that's telling us from 1 to infinity, our slope is negative, so we're decreasing. So on this one, we have to go increase to decrease somehow. F double prime is greater than 0. What's F double prime again? Is that slope or concavity? So this is going to have to be concave up, but not at 1. So something weird is happening at 1. Now, back up here at 1, we thought, okay, it's a sharp turn or a vertical asymptote. Right here, this tells us which one of those two it is. F of 1 is defined. What is it then? It has to be a sharp turn. Can't be a vertical asymptote. All right, so now we got to put all this together. So our function has to go increase to decrease. Is it just an upside down parabola? Would that work? Our concavity has to be concave up. Does that work for an upside down parabola? No. So it can't be an upside down parabola. Again, it has to go increase to decrease. Could it be this? Could it be this absolute value function like that? That goes increase to decrease, and it has a sharp turn. You kind of think, oh, maybe it's that then. But is it concave up? No. So what's the only other option then? What's it going to have to be? The cusp. It's going to have to be this, guys. Because look, this goes increase to decrease. It has the sharp turn like it needs. And it's concave up. See how it's curving like in the upward direction there? So that's the shape it's going to have to be. Okay? So you can see how these can be a little confusing. There's all these different things we could get. We can get parabolas, we can get V's, we can get cusps. You have to be able to decide. All right, so your assignment's up there on the board, page 190.